Right, so this one is the simulator. So as we mentioned, when we want to test our circuits or our concepts we learned in the lecture in the textbook. In the textbook lecture, we only introduce the basics, the principles, how the device is working. So how to test your designed circuits is really working according your design, your ideas. So we do need two ways to verify them. First one is simulation. We do it in virtual environment to test your circuit is working properly or not. Second one will be hardware to do in the laboratory. Okay, so let's think about the first one, simulator. So this is a simulator we are going to use in this course. Is good news is free for graphics student. Okay, graphics already paid the university-based license. So you must use your graphics student email to register. Yeah, in the website. It's a web-based simulator. You can do your simulation in the web browser. Okay. Again, you must use your graphics student email to register. So you will have free lesson to use. All right. So I want to show you some examples. How do we do the simulation? Okay. Let me see if I can. Okay, if I can bring up the website. Okay. Let's see. Share. Okay, can you see my screen? CircuitLab circuits. Okay, that's good. All right, I will go through it briefly, give you some basic ideas how it works. Okay. So if you go to the left hand, you will have some building blocks to build your circuits. Let's start from a very basic one. Okay, the basic, let's say this is called a digital NOT gate. So what do? You just click and drag and drop. Okay, this is your first logic gate. Circuit symbol will be there. You can see we have one input, one output. So NOT gate is a digital device which can invert our digital information from input to output. Okay. If input is low, output will be high. If input is high, output will be low. Okay, so this is a basic function. So very simple one. So let's think about how to test it. Okay, again, go back to the left hand one, pick up the input values. So this is the one we are going to use called the digital value. Okay, click. Okay, and put it into the input terminal. Okay, which means we give a 0, we give a low to the input of the NOT gate. And we want to know what will be output. We use this one, digital probe. Okay, will tell you the output is high or low. So just put it there. Okay, it will be 1. So we do the simulation. We have done the simulation very simply. So in that case, input is 0, output is 1. This is the basic NOT function. So how about if input is high? What do we do? Just double click here. Okay. Double click here and we can change the input value from 0 to 1. Okay. And go back here, you can see here's 1, here's 0. So we finished the simulation for basic NOT gate function. That's it. Also in our laboratory tasks, we will have some simple task to do this one, similar thing. Okay. And let's move on to give you some more function. Let's say if input is not, let's delete this one, delete this one. If input is a time information, let's say over time the logic will be high or low, let's say a clock information. In this case, we need to do some different thing. Let's say the input is a clock information. Okay, clock is a very important input signals in our counters or some memories. We do need a clock. So this clock means you double click this. It has very fast changing. Let's change it to 1 Hertz. Okay, make it easy. 1 Hertz frequency means the clock information will change from 0 to 1, from 1 to 0. This is 1 cycle. That takes 1 second. That's a 1 Hertz clock signal. And over the time. And how about the output? Output, we need to do something. Yeah, we need to give the name for the input. Okay, let's see. So in node 1, we can change it to be input. So when you do the more complex circuits, we need to give the terminal names. Otherwise, we may mess them up. Okay, we can type input and give the output as another name. Okay, that's the output. Okay, so we have one input. Let's drag it here, make it easy to see. All right, so we finished circuit input. Now we want to do the circuit simulation. Then go down, simulate. Click this button. Okay. And we need to do a time domain simulation because we want to see the digital waveforms over the time. Okay, you click this one, and we need to make some simple settings. So we want to see a 1 Hertz information, and we want to see multiple periods information. In that case, let's say if we put a 10 seconds, so we want to see 10 cycles. Each cycle takes 1 second. And time step, normally we need to make time step to be smaller, then we can see the transition information. So in this case, normally we make the time step to be at least 10% of the 1 cycle. So 1 cycle is 1 second. 10% will be 0.1. Okay. At least smaller the better. But if smaller, also takes time for your simulation. I think this is pretty much okay for the time settings. But this one we need to tell the system what we want to see to display on the screen. We want to display input. Okay. Also, we want to display the output. We want to see both of them. Then, okay, magic will be happening. Run time domain simulation. Okay, you can see we have digital inputs, outputs. Okay, so they are doing inversion. Okay, one is high, another is low. One is low, another is high. Okay, these two. The this color blue one is input, orange is output. We can see the details. All right, so that is basically we finished the first simulation. If we want to make them showing better, we want, because both of them overlap each other, we want to shift one to be another upper, so we can see both information in the same screen, no overlapping. So in that case, we hide this, do a small change. Let's say we want to output to shift up a little bit. Okay, you need to click this button. and let's say with +2, and this shift 2 units to the up. Then we do simulation again. Okay, you can see both them very clearly. You can see the logics very clearly. Okay, so this is a basic introduction about this software and how this software can do the time domain simulation. And you can see one is high, one's low, one's low, one's high. All right. So this is a software. It's very useful software and very user-friendly software, and also very powerful enough for learning purpose.